Hello. Following straight on from what we just did in the last video, where we worked out the percentage composition of any element in a chemical formula, let's move on to working out the percentage composition for hydrated compounds. Now, with ionic compounds, some, we've talked about this before, some can incorporate water into their lattice. They have gaps and water molecules can go into those gaps, and they are called hydrated compounds, and when we weigh them we actually have to factor in the mass of water within them, and when we look at their percentage composition, because that's part of the weighing process, we also have to factor in the water. So many of these hydrated ionic compounds, they fit in the water molecules, but it's very specific because of the lattice structure and the regular arrangement of the cations and anions, and the amount of water molecules is very specific, and it's called the water of crystallization. And the actual number of water molecules in the formula is called the degree of hydration. So if we look at something like a hydrated copper 2 sulfate, it's a blue crystalline solid and has the formula CuSO4 with 5 waters fitting in for each of these ratio in the ionic lattice. Remembering that's not a molecule; it's the ratio of ions in the lattice. So for each pair of those positive and negative ions, we get 5 water molecules fitting into the lattice. And that's what it looks like. Now this means that for each copper 2 plus ion and sulfate ion, there are 5 water molecules, just what I said. Now heating the copper 2 sulfate crystals removes the water molecules. The water molecules get kinetic energy of heat. They have too much energy and they can't stay in the lattice anymore, and they get expelled, and it becomes a white powder known as anhydrous copper 2 sulfate. So we're going from hydrated to anhydrous, meaning basically dry. And I think there's a picture of it here. And the formula for anhydrous is just CuSO4. So anhydrous copper sulfate is just copper sulfate, as distinct from hydrated copper sulfate, which has this formula here. And here's a pretty good picture of it. So it's a white powder, you add water to it and it goes blue because of the way photons interact with the ionic lattice. Changes the colour. So let's work out the percentage of water by mass in hydrated copper 2 sulfate. Now first of all, there's a few steps. Find the relative molar mass, making sure that we represent and include the formula present, the water present in the formula. So that means that there's our copper, there's our sulfur, there's our 4 oxygens, and then we have 5 times a bracket times another bracket, 2 hydrogens and 1 oxygen times by 5. And so we have to be very careful with writing these formulas and doing the multiplication correctly. But if we get the right number, which is 249.5, we're well on the way. Next step is to calculate the mass of the water, which is this bit here. So you've already calculated it before, and that represents 90. So notice there's no units because we're just talking in relative atomic masses. We can talk about it in grams and things, but we don't need to in this case. Now that 90, we're after the percentage of water, so this is the amount in mass of water relative to that. That means to convert it into a percentage, we do 90 divided by 249.5. That gives us the fraction that the water represents the total mass, and times it by 100, and we get the percentage, which they've rounded up to 36.1. That's how you do it. Should be able to have a go at an example and get your head around what you have to do and get the right answer, hopefully. Now in the next video we'll be looking at empirical formulas. Cheerio!